Hey students, thought I'd throw together another little solution video if this helps anyone. I got a kind of a couple comments on this one. So let me give it a try here. It's in our chapter 3, so it's our two-dimensional motion. And so let me just begin by emphasizing that I think one of the best ways to do these two-dimensional motions is to literally think what I'm trying to say here is you do one-dimensional twice. And so hopefully your one-dimensional motion is pretty strong or getting stronger as you do these, and then you just do it twice. So these tend to be, twice as hard as chapter 2 because we do it twice, but on the same sense, we're really just doing the same thing. But keeping track of them is the hard part, and this is a good example of that. Watch this. It says a basketball player is running at 5 meters per second directly towards the basket. Now, if I pause right there, I'm going to then put this in the X column because this would be running horizontally, okay? And it kind of implies that they're running, across the floor towards the basket. So that's the X direction. Then jumps into the air. Okay, so pushes off the floor with some kind of unknown speed at that particular moment. Okay, so heads up into the air. He maintains his horizontal velocity, and that's good that the author says that. It makes it a little bit easier. But on the other hand, hopefully that is well ingrained in you about projectile motion, because projectile motion is the effect of gravity. Gravity pulls only vertical. So also indirectly implied in this problem is that the acceleration in the y direction is negative 9.8 meters per second squared, and that there is no tug or pull of gravity in the horizontal direction. And so that's some other known information that we have. Now, maybe I should have a picture here so that I can help me put my equations, and I'll just make kind of a person with a dot. So they're running along, and then, boom, they jump. And then they're going to follow this parabola shape, okay, where their horizontal and vertical motions are described here. Now, if we put the origin of this problem, maybe I'll do red, kind of right here where this person starts the jump. I guess we could also write down our knowns by saying, okay, the initial, and I think your book uses an I for initial, so maybe I should. I get my textbooks mixed up, which one uses I for initial and which one uses the not. So the initial position is 0 for both X and Y. And so you can kind of hopefully see what I'm doing here. I'm setting up what I know, and of course what I don't know, and what I might need, and also putting things that are given, but kind of in an indirect way, which are these accelerations. And I'm putting in their corresponding motion. Because like I said, the most common mistake, even after students learn how to do one-dimensional motion, is then to start to do two-dimensional motion, but they mix a parameter. They put something that should be with the X and the Y, or vice versa. Like they'll use 9.8 over here for the acceleration in X. And that's where you have to be careful. The only thing that would mix back and forth is the time. And so the time is a scalar, not a vector, meaning that as you go up, the time to get, say, to the top, is the same amount of time as it takes you to get over. So time is one thing that we can move back and forth between these two columns. But it's acceleration upward and its acceleration sideways can't be mixed. Or their velocities, initial velocities can't be mixed. All right, so finally getting to the problem. All right, what vertical velocity does he need? So there it is, right there. That's what we're asked to find. What vertical velocity does he need to rise 0.7 5 meters above the floor. Okay, so that last part is saying that the final height is 0.75 as they go up. And we want to find this. So they gave us some more information about vertical and then asked us something vertical. And so we have those 5 kinematic equations. And maybe they're worth kind of repeating. We've got the final velocity equals the initial velocity plus acceleration times time. We have the change in position, and maybe if I'm putting it in this column, I should write it as y final minus y naught. If I was writing it in this column, I might write it as x final minus x naught. But it would be the initial velocity, initial, in the y direction times time, plus 1/2 acceleration times squared. And so that's kind of our 2 basic ones. Then, of course, we can make 3 of those because we can solve for each of these variables and put it in. For example, if we solve this for time and put it into here, we would get final velocity squared equals initial velocity squared plus 2 times acceleration and then the distance traveled. So y final minus y initial. If we were to solve this one for acceleration and put it into here, we would have distance traveled equals to 1/2 of the initial speed plus the final speed multiplied by time. And then the final option we can do is to solve this one for final speed and, initial speed and put it into here. So we're going to do each of these 3 and put it into here. That's how we get these 3. And if we solve this for initial speed and put it into here, we get something that looks a little bit like this second one, except instead of having initial speed, it has final speed, and instead of having a plus, it has a minus. And then the hint I like to give is that, okay, when do I use each of these? Notice there are 5 variables, and hence 5 equations, but then also notice that you're often given 3, and there it is, 3, 1, 2, 3, and you're asked for a 4th, but you don't know anything about the 5th. And each of these equations is missing one. For example, this one here is missing the distance traveled. This one here, maybe I'll make a little column missing. This one here is missing final speed. This one here is missing time. This one here is missing acceleration. And this one here is missing initial speed. And so my strategy is to think about, okay, which one is the one of not of interest? In other words, what are the 3 they gave you? What is the one you're looking for? And so what is not there would kind of tell me which equation to use, because the one that's missing means that I can't solve for it, but it also means I don't need it to put into my equation, and that's kind of my clue. And so my clue here for part A is to do this 3rd equation, because as I look at what I have, 1, 2, 3, I have these 3 things here, okay? Actually, my apology. I guess that doesn't really show the 3 things. This right here, I'm treating as 1. Okay, so the distance traveled is 0.75. Okay, so I have these 2. I'm looking for this 3rd. And it looks like then final speed in the y direction is not really listed here, as well as time. And I spoke a little too fast because, like I said, this wasn't 4. This was just these 2. Fortunately, though, they do give me this one. It's not so obvious. It's kind of indirect, kind of like this here, where they give me the acceleration in the x direction. This, they say, to rise, let's see, the vertical velocity does he need to rise. So when he rises up, when he gets to the top, he'll have a 0 speed, okay? So they indirectly gave me that one. And so that's really what I needed to say. They gave me these four. They gave me the final speed. They gave me the acceleration in the y direction indirectly. Actually, both of these were indirect. They gave me these kind of directly, and they're asking for this. But again, what I was saying is the one that's missing is time. So this would be the ideal equation. And so doing part A, chapter 3, number 46, I would say, all right, here we have it. Final speed squared is equal to initial speed squared plus 2 times acceleration and then the distance traveled. And I would go, okay, I'm looking for this initial speed. The final speed is 0. The acceleration is negative 9.8, and the distance traveled is an upward 0.75. Now, by the way, as a side note, because I saw a couple of you work out the solutions, the same effect going up is kind of symmetric as going down. And so some of you put the initial speed as 0 and final speed is what you were looking for. And that would be more of a description of coming down. Although the final speed coming down really is the same as going up. So it's not really wrong. Although because you're going down, you would have to put a negative 0.75 here. But if you do all that, you'll get the same answer. But I think it makes more sense thinking about going up because that's how they described it. And so using then my calculator here, I can go ahead and say this is 2 times the 9.8. Oh, I forgot the negative, so let me just go times negative 1. And then times the 0.75. And this negative is important because then when I move it to the other side, it becomes a plus 14.7. Which is also why, if you were thinking about it going down, you need to put a negative 0.75 because you would be having it on this side, and so you need to get a positive over here to take the square root. Otherwise, you're going to run into troubles taking a square root of a negative number. Oops. Oh, let's see, like I just did. I forgot to move it to the other side and take the, change it to a positive. So that should be 14.7. Anyways, I get an initial speed of 3.83 meters per second. So there's what is the velocity in the vertical direction? And I know I moved over to my yellow sheet, but I hope you kind of visualize that being in this column here, okay? And so I guess I could put it over here and say 3.83 meters per second is the initial velocity in the y direction. And I guess I really don't need y's over here in this column. And that's kind of implied, just like I guess I don't need x's in this column. That's kind of implied by this column x. Okay, so then moving on to B, how far from the basket, and there it is, measured in a horizontal direction. Okay, so right there, I am looking for the final position and the difference between those two. Okay, so that's what I'm looking for. Must he start his jump in order to reach this maximum height at the same time that he reaches the basket? Okay, so this clue is same time. And so notice that what I just did in part A was deliberately to use this equation that avoided solving for time, but it looks like I'm going to need it. And this ties in with what I said earlier, is only the quantity time can you shuffle back and forth. Because the time, again, to get to the highest point is the time that it takes for him to move across as they are asking. So I could go ahead then and continue to do a calculation in this column for the y motion and get time and then use it over here. And so I'm going to do that because if I then can put it over here into this column for time, you'll be able then to see that I know for things, I know the initial velocity, I know the acceleration, and I know the time, and I'm looking for distance traveled, okay? And so I'm going to end up using equation number 2 for that statement. But before I get that far, let me come back here and then solve one of these for time. And at this point, any of these 4 equations would work because I have the other 4 parameters. I've got the initial speed, the final speed, the distance traveled, and the acceleration. And the only unknown is time, and that means I can use, that one, or I can use that one, or I can use that one, or I can use that one. Why don't I just do number 1? It looks the easiest. And so, all right, the final speed is 0, y direction. The initial speed is what I just went through and calculated. He's jumping up at 3.83. The acceleration is negative 9.8, and solve for time. And so moving things around to complete the math, I will get time equaling this 3, grab my calculator, 3.83, and divide it by, and notice it come out to be a positive 9.8 by the time I moved it to the other side, and I get a time of 0.391 seconds. Okay. So there's my time, which, as I said, is what probably makes the two-dimensional motion hardest, and that is shifting it over and knowing not to mix things other than time. All right, so finally we can finish this when we say how far. I'm going to go ahead and apply equation number 2 here. So x final minus x initial is equal then to the initial speed, so that's 5, multiplied by the time, which we just solved for, 0.391, plus the acceleration, and of course I'm doing it in this column, so this would be acceleration for the x motion, and so that's a 0. And so there's how far they traveled. So I'll just take that time and multiply by 5, and I get a 1.95 meters. And so there it is. The, answer to A, answer to B, and needing time to connect the two together. And hopefully a lot of other helpful details that will be useful when you solve all the other problems. So again, that's the strategy for any of the two-dimensional motion. And if that made sense to you, if you follow that strategy, you can do any of these two-dimensional motions. It doesn't really matter whether it's a basketball player or a rock being thrown or whatever, any of the just 2 columns. All right, take care.